All right, phase diagrams. Here's the idea. On this axis, you have pressure. And you have a different one of these for every element and every compound. Okay? It is the pressure and temperature at which it exists in various forms. So, at various pressures, the boiling point and freezing point changes. So, when you are cooking your favorite, Bobby, we have to figure this out for your science project.
Why?
Because the results are only valid at the current pressure. So, note the pressure.
How do I do that?
Go online and be like, what's the pressure in Tucson today? And then when you do it.
Oh, so that means I have to like.
Because it's going to change your results if you have a different. So as long as you do them all at the same pressure, it's fine.
Dang, that's 10 loaves in one day.
You don't have to do them the same day. Just make sure there's no like
change
weather coming in. So like if there's rainy weather coming in, then that'll drop the pressure. If it's super sunny weather, then it'll raise the pressure. So make sure you do it over a period of time when weather is consistent. Okay. So here's the idea. At various pressures, the freezing and boiling points change. Okay? This diagram demonstrates this. A couple of things you should know. Number one, this curve here is when what happens? Well, when we go from gas to solid, that is called gas to solid is
Gas to solid. Condensate. No, wait.
He's
positing.
This is positing out of thin air. Okay? The other way is sublimation.
Subtraction.
Okay? So, notice, what do you see about this? Is that happening at normal pressures? No. Okay? Let's say normal is around here at 1 atmosphere. Okay? So we'll vary a little bit based on the weather or based on your altitude, but you're not going to go to like half of an atmosphere anywhere on Earth. Okay? Unless you like go way up. Okay? And have a large change in altitude. So what this is saying is that normally here is where we're at. So in order for sublimation and deposition of water to occur, you have to be down at 6 times 10 to the negative third atmosphere. So super, super, super low pressure is the only time this is on the board. So it should be in your notes.
So just
Yeah.
those two words.
The chart. The chart's on the board. See, it's on the board. So you gotta. And I drew this part and those things. And pressure and temperature. Yeah.
Okay, so above critical point, what does that say? Is it
Oh, I'll write them all. You'll see.
Thank you.
Okay, we're going with it as we get there. Okay, so sublimation and deposition, things you should know. These are going to happen at super low pressures. Why do we not talk about them that much? Because they happen at such low pressures that they're really not happening. Okay, for some compounds, it will happen more frequently. Okay, it'll happen more frequently because the pressure required for that is higher. Okay, then we have this curve here. This is your melting or freezing line. Going to the left is called freezing. How do I know that it's freezing? You are dropping the temperature. Temperature is down here, so as I move to the left, I'm decreasing the temperature. It is freezing. When you increase the temperature of something that is solid, what happens? It melts. So there's your freezing melting line. Then you have this curve here, which notice is very different as pressure changes. Okay? As you get higher pressure, your substance wants to be more gassy. Okay? Lower pressure. Lower pressure. Sorry, as your pressure is lower, you want to be more gassy, and as your pressure is higher, it will stay as a liquid longer. Why? Because if you are pushing down on something, then the volume is lower, okay? Probably in a liquid form, right? The more you push on it, the more it's going to want to be a liquid. But as you decrease the pressure, it has more room to expand. It will become a gas. So that's that line. This line is your evaporation or vaporization. And then you have the condensation going the other way. So we did talk about that in chapter 1. You are correct. I forgot if we did it or not. So why do we care about this now? Well, because temperature is a measurement of energy. Okay? Temperature is how much thermal energy there is. Right? That's why you put on a thermal if you're cold, right? Because it warms you up. So solids are very low temperature and thus low energy, right? The atoms are not excited at absolute zero. They've stopped moving. But as you increase the temperature, the atoms get a little more friendly. They start moving around a little bit more. COVID restrictions lift. They're bumping into each other again. And then finally, once you get to gases, they're flying around everywhere, right? Because they are very excited. They have a lot of energy. What did you say?
Joy.
Joy. I like that. Please don't be gassy in my class. I would not appreciate that kind of joy. Now, other points that you should care about on this graph. This is the line that represents 1 atmosphere. So at sea level, this is 1 atmosphere. That is your normal pressure at sea level. So you go to San Diego, you sit on the beach, unless it's raining or unless it's super, super hot, you're at 1 atmosphere. Okay? So what does that tell us? Well, this gets us our melting point of water, which we will normally say is what? Water melts or freezes at?
0 degrees.
Yeah.
Wait, what is that in? What is that in?
Celsius?
Celsius,
Celsius.
0 degrees, right?
You said melt or freeze?
Melting point?
Melting and freezing point is the same.
Wait, melting.
Because above that point, it melts.
Oh,
Below
right.
that point,
Yeah.
it freezes.
Okay. Yeah.
So this is 0 degrees Celsius. Okay, but you'll notice that as the pressure, I mean, that's pretty much vertical, but as the pressure changes, it varies a little bit. Yeah?
I just want to clarify, can you go to the negative ATMs, be underneath sea level? Does that go into negative?
Nope, you actually get more pressure again.
Oh, okay, so it's like the same
Yeah.
both sides? If you go up 2 feet and then below 2 feet, you're in the
No.
same atmosphere?
Because water weighs more than water. Or water weighs more than air.
Oh.
So it will push down on you more, so there will be more force per area, and you will have increased pressure. We learned that last year. Force over area.
Oh, I kind of forgot physics. Give me some
Wow.
I'm sorry.
Okay. No, you cannot have negative pressure. You can have bad pressure where the pressure gradient is different and then things go backwards, but you cannot have negative pressure. Okay. So this is standard conditions. What's this? This is your boiling point. What is it for water? 100 degrees Celsius. Change the pressure, you get very different results. So when you try and boil water at a lower pressure, perhaps in Colorado, will it take less or more energy to boil your water?
Less.
It will take a lower temperature to boil your water. So if you're cooking something, you must adjust accordingly to the external pressure. So if you go up to a higher altitude, lower boiling point.
Where's Arizona's on that shirt?
I have no clue.
How do you know Colorado's not here? You live here.
Because it's higher than Colorado. No, I just eyeballed it. That's not real.
Wait, so if you
Did I put a number there? No way.
so
Yeah.
if you go to Mount Lemon, like is there a difference?
It's going to change,
So-
the
Huh.
boiling point. Not
And
cool?
why is it universally like 100?
Because that's at 1 atmosphere. You have to say at some pressure. So we assume 1 atmosphere. So none of this is real. Like if you're in Tucson and you try and freeze something at 32, that might happen. Fahrenheit, but you definitely won't boil water at 100 Celsius. It'll probably be less. Fun fact. Cool. So important points to note. This is the triple point. This is the critical point.
What's that?
It's critical.
All right, see you guys later. We're out of class. Oh, yeah, actually, no. After the critical point, it's called a supercritical fluid. You can't really tell the difference between liquids and gases at that point.
Yo, that's
Which is weird.
cool.
But that's like super, super high pressure. So, anyways, that's it. We'll continue tomorrow.